Okay, section 3.2 is called measures of variation. Another way statisticians use to describe data accurately are measures of variation. To determine the spread or variability of a data set, three measures are used. First is the range, which is the largest minus the smallest. The range is largely affected by outliers. Second is the variance. That's based on how far each data value is from the mean. There's the formula. It looks scary, but you don't have to use the formula. This stands for sigma squared, the sum of, that's the data value, that is the population mean divided by the number of items. The calculator we'll be able to use the calculator to compute this. Okay, the sample variance looks the same except we use S squared. This is still the mean. This still stands for the number of data values. Okay, the data values are near the mean, the variance is small. If they're far from the mean, the variance is large. All right, the third one is the standard deviation, which is the square root of the variance. So it's the same formula, you just take the square root. Okay, the larger the variance or standard deviation, the more variable the data are. A statistic that allows you to compare standard deviations when the units are different is called the coefficient of variation. There's the formula. It's the it's the standard deviation divided by the mean times 100%. The range can be used to approximate the standard deviation. This is called the range rule of thumb. So you take the range divided by 4. That's a quick estimate of the standard deviation. Chebyshev's theorem specifies the proportions of the spread of data in terms of the standard deviation. The proportion of values from a data set will fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1. At least 3/4 or 75% of the data will fall within 2 standard deviations. 8/9 or 89% will fall within 3. Chebyshev's theorem applies to all distributions. When a distribution is bell-shaped or normal, the following empirical rules are true. 68% fall within 1 standard deviation, 95 fall within 2, 99.7 fall within 3. All right, we got a curve right here that we need to talk about and fill out. This is called the normal curve. This right here always represents your mean. This is the mean plus 1 standard deviation. This is the mean plus 2 standard deviations. And this is the mean plus 3 standard deviations. This is the mean minus 1 standard deviation, minus 2, and minus 3. Now this is only when you're dealing with a normal distribution. Okay, we got some more values to talk about. We know that within here represents 68% of the data. So since these two sections are symmetric, this section's 34 and that section is 34% of the data. From here to here, which is 2 standard deviations above and below the mean, it is 95%. So if this is 68, to find these two sections, I can subtract 68 from 95 and half it. So this is going to be 13.5% of the data as well as this. Okay, Okay, and lastly, if I go all the way from here to here, that is 99.7% of the data. And if I calculate this section is 2.35%, as well as this one, which leaves these tails right here as 0.15%. Okay, now this and Shabishiv are not the same thing, so let's do a few problems to see if we can make some sense. Okay, so get your book. Okay, get out of this. All right, let's take our book. Let's start on page 143. All right, page 143. Let's do problem 7 first. Problem 7 says, the average weekly unemployment benefits for a random selection of states are listed below. Calculate the range, variance, and standard deviation. All right, so punch the data in the calculator in L1, compute one varstats. We're gonna look for SX, which means the standard deviation, okay? If I punch that in and round it off to the nearest tenth, I should get 59.8. That's all I can see on the calculator. All right, I can use the max and the min to find the range. So that would be 416 minus 190, which gives me an answer of 226. Okay, and the last thing I gotta find is what's called the variance. I take the standard deviation and square it. So that's gonna give me an answer of 3,576.04. Okay, all right, let's move on. Let's look at number 13. So number 13. 13 says the average age of U.S. astronaut candidates in the past has been 34, but candidates have ranged in age from 26 to 46. Use the range rule of thumb to estimate the standard deviation of the ages. Okay, from your PowerPoint, this is the formula. Okay, so we'll take the range, we gotta find it. To find the range, you'll do largest minus smallest, which is 46 minus 26, divided by 4, that gives me 5. So that's just a quick estimate of the standard deviation. Let's do 19. 19 says, the cost per load per cents of 35 laundry detergents tested by a consumer organization are shown here. Find the variance in standard deviation. All right, just like we did in section 3.1, I have to find the midpoints of that first column. Okay, remember what I do, like on that first column, the limits are 13 to 19, so I'm gonna add those and divide by 2. That number is 16. Okay, etc. I'm going to punch that in L1 and L2, choose frequency L2. I'm looking for the variance and the standard deviation. Can't find that from the calculator, but this, the calculator tells me, is 11.6. Okay, if I square that, I'll have the variance, which is 134.5. next problem we'll do is 27. Alright, 27 says, the average number of days that construction workers miss per year is 11. The standard deviation is 2.3. The average number of days that factory workers miss per year is 8, with a standard deviation of 1.8. Which class is more variable? Alright, we have to use a formula called the coefficient of variation. The formula is this. So what we have to do is turn these into something that we can make a comparison, and this formula will do it for us. We got two kind of people that we're talking about. We're talking about, let's see, construction workers. Okay. So it tells us that their standard deviation is 2.3. Their mean is 11. I'm going to multiply by 100. That's going to be 20.9%. Okay? The other category is factory workers. It tells us that their standard deviation is 1.8. Their mean is 8 times 100%. Gives me 22.5. Okay, now our question asks us which is more variable. So we're looking for the ones that's more spread out, which means I'm looking for the largest percentage, which is going to be the factory workers. Okay. And that's the answer because their percentage is